Hello and welcome. In this tutorial, I'm going to show you how to perform a linear regression using Python. Now, although this is a Python explained tutorial, this is a follow-up from the statistics explained tutorial where I showed you how to perform a linear regression calculation by hand. Okay, so the first thing you'll need to do is import the sklearn module, and you may need to do a pip install function to get it installed into your Python shell, and then once you've done that, you need to restart your Python shell ready to use your newly installed module. After you've done that, we need to go to import two areas of our sklearn module. Those are datasets and linear model. So what we're going to do is type in from sklearn import datasets, which is the first one, comma linear underscore model. And then we're also going to need to import the numpy module as well. So I've typed in import numpy as np, and np is the alias we give the numpy module. So wherever we reference np in our code, we're calling the numpy module. Cool, so now those are the modules imported that we need for our linear regression. We now need to go ahead and get some x and y values. So the x and y values we're going to be using for this tutorial are x is 1, 2, 3, and 4, and y is 10, 15, 20, and 25. Exactly the same x and y values I showed you and we used when we did it by hand in the statistics explained tutorial on linear regression. So you should get similar numbers and similar answers. And there's a good way of checking to see if you're happy with this and you're getting the right results that I showed you last time. Okay, so the first thing we need to do is we need to reform the x and y data into 2D arrays. That's because we need to get it so that it is a row and column value and not just a straight up list. So all we need to do now is we need to reshape the x values to be sort of representative of rows rather than columns. So we can do that by typing in np, calling the numpy module, dot array, and then in the array brackets, we put in the square brackets of our list x here. We type in dot reshape, and then in the brackets of reshape, we have another brackets, and we type in -1, 1. And what that will do is that will reshape the x values to be two-dimensional arrays. And that's very important and a crucial aspect of not just linear regression, but other regression as well. It's kind of like a standard thing you have to do for all regression analyses in Python. The next thing we can do is we can just create an array for our y values, but we don't need to reshape it like we did in the x values. So if we type in np.array, and then in brackets have the y values in square brackets, and we can give that the variable y underscore reshaped, and we can give the x values that are reshaped x underscore reshaped. So whereas x is just 1, 2, 3, 4, and y is 10, 15, 20, 25, we've got new variables now we're going to use called x underscore reshaped and y underscore reshaped. Cool, I hope you're with me there. Moving on. The next thing we need to do now is we need to create a sort of model, in this case a linear regression model, ready, we're going to create the environment ready for the values to be put in and used. And so that's what we're going to do next. If we type in linear underscore model, calling our linear model part of our sklearn module, dot linear regression, capital L, capital R. So if you type in linear underscore model and then type in linear regression, my computer's going really slow for some reason, like that, we've now starting to create an environment ready for our values, our x and y values to be put in, and for essentially a prediction to be made. Cool. If we give that the variable regression1 equals to linear underscore model dot linear regression, we can now use that and combine it with our x and y reshaped variables to create sort of a fitted regression model. So this is putting our linear regression environment together with our x and y reshaped values, our arrays. So this is like the main part where everything happens, just in one line. Super powerful line, really awesome. So if we type in regression1, calling our linear regression model, dot fit, and what fit's going to do is it's going to fit our x and y arrays into our linear regression model. Pretty much exactly what it says on the tin. So if we type in regression1 dot fit, then type in brackets x underscore reshaped, comma y underscore reshaped, we've now got our regression model created with our x and values in there. But now what we can do is we can give this a variable and we can start using this regression model to draw out some values. And the first value we're going to draw out is the slope. So what we can do now is we can calculate the slope. So if we type in print and then we type in slope in quotation marks, comma reg1 underscore fitted, which is our variable to create our regression model for linear regression, dot coef underscore. Now remember the underscore. So remember it's reg1 comma fitted dot coef underscore, and all in brackets. We can now calculate the slope. Then we can do exactly the same thing, but instead of having coef underscore, we have intercept underscore. We can now also print the y-intercept. So let's run this. Let's see what happens when you run it. Keep going. Here we go. So here we have our slope is 5 and our y-intercept is also 5. This is good because this is the values that I was expecting, and it's the values that match our values that when we did it by hand, we also got. So there's proof also that this works and is correct. Nice. Notice that the slope is in square brackets. That's because it's an array calculation, and the y-intercept is not in square brackets. It's a straight number. That doesn't matter. It's just something to bear in mind if you want to ever use those calculations for further analysis. Okay, now that we have values, we can now... Okay, so now that we have values, we can now use these values to create predictions. So it's all good and well that we've got a good linear regression model, and we can calculate the coefficient and the slope, we can calculate the y-intercept. But the whole point of this analysis and this linear regression model is to create predictions. And so that's what we're going to do in our next bit here now. Is we're going to, instead of having this x reshaped up here, we're going to recalculate that variable x reshaped to be np array, and then put some bigger numbers, that go way ahead on the curve, dot reshape it, exactly the same way as we did above. So instead of 1, 2, 3, 4 for x, we've got 1,000, 1,250, and 1,500 for our x values, just 3 of them this time. And we're going to also predict our value y by now fitting our new x values into our fitted regression model that uses these existing x values as a template. And we can now print our predicted y values. So let's run it again and let's see what we get. Cool. So here we get 5005, which is exactly what we got last time in our by hand calculation. So we know it works. We also get 6255, 7505. So this is how you do linear regression analysis in Python. So it's a really great join of statistics and Python together. So I hope you enjoyed that tutorial. Please smash that subscribe button and please do share me to anyone else you think may benefit from it, these videos I mean, and also please do like and comment. Thanks very much for watching.